Hello everyone and welcome back to CE439. In this video you're gonna learn chapter 7 which is about aggregation production. Okay, let's see what are the learning objectives. Number 1, understand the basic types of rock crushers and the principles on which they operate. Number 2, ability to use a manufacturer's crusher capacity chart. And number 3, ability to design a crushing plant based on the required size distribution specifications. The last objectives in your notes has been removed from this course. These learning objectives are based on section 7.1 in your text. You are responsible only for this section, and you can read other sections of this chapter just for your information. Section A, basic functions in aggregate production. One main purpose of this process is to reduce the size of the material. Rock crushers such as the one shown in this picture are typically used to reduce the rock or gravel to a smaller size. Size separation is another main purpose of aggregate production. Aggregate is typically a mixture of materials with different sizes. They will be separated through a sizing, which is also known as a screening process. For sizing purpose, the aggregate mixtures goes through a system with multiple layers of screens. These screens have different sizes. Screens with large size are on the top and smaller size in the bottom. Large aggregate that cannot go through a certain screen will be collected and dumped in a separate pile. This is one example of sizing machine. Eliminating any undesired materials is another main function of aggregate production. So this is typically done by washing the aggregate with water. Sometimes magnets or metal detectors are also used to eliminate any metals in the aggregate. Finally, the aggregate production includes handling and moving materials, which transport the materials between different stages of the production process, as well as storage the final products. In this picture, the final products are transported to a final stockpiles. Section B, let's learn more about the size reduction process. Rock crushers can be categorized into the following types: primary crushers, secondary crushers, and tertiary crushers. This figure illustrates the crushing cycle, which typically includes three different crushing processes. Raw stones are first fed into the hopper, and then it goes to the first screen. Small sized stones that go through this screen will be transported to another screen, while large rocks will be going to the primary crusher where the size will be reduced. The final products of the primary crusher is passed to the second screen. The oversized material at this screen is passed to the secondary crusher for another stage of crushing. If yet another stage of screening and crushing would be needed, the product will be passed to the third screen, um, which is known as the tertiary crusher. So if there are still oversized material, they will go back to the tertiary crusher until it passed through the final screen. In this class, we will cover the following topics: crushers, crusher production, screening, and screening sizing. Other functions such as washing is not covered in this class.
A crusher can be operated as a closed circuit, which means the oversized material is returned to the crusher, or it can be also operated as an open circuit when no material is returned for recrushing. In the crushing cycle, as we discussed earlier, the primary and secondary crushers are open circuit because materials go through these crushers only once. Tertiary crusher has a closed circuit. As oversized materials resulted from this crusher will be returned to the crusher until everything passes through the screen. Okay, section 2, types of crushers. First, let's see how to break rock into smaller size. It is like open the shell of this walnut. To do so, you can use the following two typical methods. Method 1 and use a hinge nut cracker. So these two creates a compression force on the walnut shell. Another tool is spring nut cracker. You can also use a hammer. So this method makes an impact force to open the shell. For rock crushing, the following types of crushers are commonly used. Number one, jaw crushers. So this is used only for primary crushing. Number two, gyratory. This is also used only for primary crushing. Number three, cone crusher. This can be either used for secondary or tertiary. And number four, roll crusher. So this is an old types of crushers and it is no longer used nowadays. Number five, impact crushers. This is used for both primary and secondary crushing. Finally, mills, which is also known as a grinder. This type is used only for tertiary crushing. Of those six types of crushers, the first four crushing rock by making the compression force, and the last two use the impact load. Table 7.1 in your text gives you some principal types of rock crushers and their characteristics such as the maximum size of the rock to be crushed, the expected product size, as well as the crushing stage that the machine can be used. Jaw crushers. These figures below here illustrates a jaw crusher. It is composed of two vertical jaws. Rock will flow into the space between these two vertical jaws. One jaw is stationary and the other jaw is movable. These movable jaws moves in an elliptical downward motion towards the stationary jaw while crushing, and then upward and away from the stationary jaw to allow the crushed material to exist. And this is another animation of the jaw crusher. And this is a picture of a real jaw crusher. As noted earlier, jaw crushers are primary crushers that receive material directly from the quarry. The material fed into these types of crusher is typically raw rock, which are large sizes. Jaw crushers can be fed from an excavator. or it can also be fed from a dump truck. So let's watch a short clip following about the jaw crusher. Jaw crushers are classified using the size of the feeding opening, which is measured using two numbers, including the depth and the width dimensions in inches. For example, a 30 by 42 jaw crushers has a feeding opening of 30 by 42 inches. The size of the output is controlled by the bottom opening where the material exits. The size of this exit opening varies between different states when it is stopped or when it is in operation. Where there are two parameters used to measure this opening. The first parameter is open size setting. This is measured when the machine is stopped. The other parameter is closed size setting. This is considered as the average size of the opening during operation. It is equal the open it is equal the open size setting subtracted by a certain amount depending on the machine model, and the size of the output is controlled by this closed size setting. These parameters are typically provided by the manufacturer. Crusher manufacturers provide either tables or chart that provide typical capacity values in tons per hour for their various crushers. This is an example capacity table for Lanahan Universal Jaw Crushers. This chart gives you the estimated production in tons per hour for different models and closed size settings. And this is one example of performance chart for TestMate 3450, and the vertical axis in this chart are closed side setting in millimeters or inches, and the gray area indicates the capacity range. For example, with a closed side setting of 4 inches, its capacity is estimated to be from 300 to 450 tons per hour. Note that this chart is developed with an assumption that the material density is 100 pounds per cubic feet. So if your materials has another material density, you need to make some adjustment. Again, rocks with different unit weights, smaller or greater than 100 pounds per cubic feet, will require an adjustment to be made to the values provided in the tables. Remember, the output material exiting the culture may not be uniform. It includes materials with various sizes. To know the percent for each size in the output, you need to read the machine manual. Most manufacturers provide typical gradation values for the material exiting their cultures. Table 7.2 in your textbook provides an example of typical gradation values for jaw crushers. And this is table 7.2 in the textbook. This table gives you the gradation of the jaw crusher output. Okay, how to read this table? The first column indicates the potential sizes of the final product. Other columns are different size of the closed size setting. The numbers in the table indicates the percent passing or the percent of the output passing a certain screen. Suppose that the closed size setting of the crusher is 3/4 inch. Under this column, as you can see, there's no numbers for the screens from 10 to 2 inches. So this means that the with 3/4 inch closed size setting, all the products pass through the 2-inch screen, and there's no aggregate larger than 2 inches. So let me zoom out this logo part to have a better view of it. For screens smaller than 2 inches, now you start seeing a percent values. For 1.5 inch, the percent passing is 100%. So it means that 100% of the output of the cursor will pass through this screen. And at if you move down a little bit at 1.25 inch, so there is 99% passing. In other words, 99% of the total product will pass through this screen. So the portion of the aggregate between 1.25 to 1.5 inch will be 100%, which is the percent passings of the upper size subtracted by 99%, which is the percent passing at the lower size, or 1%. So if you keep reading these columns to the end, you will know the percent passings for others material size. Section B, giratory closures. Please note that in figure 7.3 of your textbook, the figure in the bottom left is captioned as cone or giratory crushers. This is wrong. This is a cone crusher, is not giratory crushers. So I will discuss how to distinguish these two crushers later. Giratory crushers have a gyrating mantle mounted within a deep bowl. As it gyrates, the mantle crushes the rocks against the size of the bowl. Giratory crushers are primary crushers that receive materials directly from the quarry. This is a vertical section of the crusher. Giratory crushers are sized by their feeding opening and the diameter at the base of the mantle in inches. For example, if the feeding opening is 16 inches and the mantle diameter is 89 inches, this crusher is called 60 by 89 inch crusher. Similar to jaw crushers, giratory crushers also have two parameters, closed side setting and open side setting. The open side setting is measured when the machine is stopped and it is larger than closed side setting. The actual output is controlled by the closed side setting, but the production capacity stated in the manufacturer table is based on the open side setting. So this is one example's capacity chart for the meso superior giratory crusher. Given the machine size and the open size setting, which measure in inches, you can find the machine capacity in tons per hour. Remember that the auto capacity charts are based on the unit weight of 100 pounds per cubic feet, so adjustment will be needed for materials which has the unit weight different from this reference value. A typical output gradation for giratory crushers. The typical output gradation for giratory crusher will vary a lot depending on the material being crushed, the quarry condition, and the amount of fines in the feed material. So table here shows the percent of product passing a screen with the size equal to the open size setting of the crusher for different types of materials. So if the material is soft, such as limestone, it is easier to crush. Thus, the percent passing is very high, about 90%. However, if you are crushing harder rocks such as granite and trap rock, this percent will reduce to 85% and 75% respectively. The curves in this chart are developed based on the screen analysis of the crusher output, so they can be used along with table 1 to provide an initial approximation for the output gradation. Okay, let's do an example here on how to use the chart and the table. As in this example, a gyratory crusher with a 6-inch open side will be used to crush limestones. You are required to develop an estimate for the gradation of the crusher output material. To answer this question, first you need to use table 1 to determine percent passing 6 inches, which is the open side setting in this example. From this table, given limestone as the material, the percent passing 6 inches is going to be 60%. This chart gives you the correlation for various types of materials. Each curve is developed for a certain types of material, and the vertical axis is the screen size, and the horizontal one is the percent passing. Now in step 2, you need to identify the curve that is corresponding to limestone. So you need to use 6 inches and 90% passing found in the previous step to determine the curve to be used. In this chart, you draw two lines at 6 inches and 90% passing. As if the intercept is on a certain curve, you use it to find the production gradient. In case the intercept does not fall on any curve, you pick one that is nearest. So in these examples, you can use the pull line as it is nearest to the intercept. Step 3, now you can use the curve identified before to determine gradation. Suppose that you need to find the percent passing for the following screen size. So let's do 7 inches first. At 7 inches on the vertical axis, you draw a horizontal line until you meet the blue curve. At the intercept, now you can go down to the horizontal axis to find the corresponding percent passing. Here we got say 97%. So you can repeat this process for other sizes. You got 91% for 6 inches, 80 for 5 inches, 67 for 4 inches, 52% for 3, 37 for 2, and then finally 22% for 1 inch. Okay, so let's watch the following clip about a gyratory crusher.
Looking down into the crusher, the outer circle represents the stationary bowl covered by the concaves, and the inner circle represents the main shaft covered by the mantle. The main shaft rests in the eccentric bushing at the base of the crusher, and as the eccentric rotates, the base of the main shaft moves in a circular path around the crusher center line. Viewed from the side, the motion of the main shaft is like that of a pendulum. As the gap closes, the ore is nipped and broken. When the gap between the mantle and the concaves increases, the broken ore is released and falls lower in the crusher cavity where the gap is narrower. Ore that is fine enough falls through the crusher where it is usually picked up by a feeder or conveyor belt. Ore fed at the top of the crusher fills the vacant space.
Now let's move to section C, cone crushers. Cone crushers are secondary or tertiary crusher. They receiving their input from the output of a jaw or a gyratory primary crusher, or from another cone crusher acting as a secondary crusher. Remember that we don't use cone crusher for primary crushing. The bottom left figures in figure 7.3 in your textbook illustrates a cone crusher. Again, it is not a gyratory crusher. It works like a gyratory crusher with an eccentric rotating cone around a vertical shaft to cause a gyrating movement of the head. The following are several pictures of real cone crushers. Okay, so here are the main features that distinguish between a cone and a gyratory crushers. First, the cone crusher has a shorter head. So in this slide, the gyratory crusher is the one on the left and cone crusher is one on the right side. So as you can see, the cone crusher has a much shorter head than the gyratory crusher. This slide compares the mantle of a gyratory and a cone crusher. The mantle of a cone crusher is also much shorter than the gyratory. Compared with the gyratory crusher, cone crushers have a smaller receiving opening. So the capacity is typically lower than gyratory crusher. So these two figures are to compare the receiving opening between a gyratory and a cone crusher. So here the opening is defined as the gap between the mantle and the outer shell. As you can see, the gyratory one on the left side has a wider opening. Another feature that distinguishes between gyratory and cone crusher is the speed. Cone crushers are typically rotate at a higher speed than gyratory crushers. Cone crushers are sized by the diameter at the bottom of the cone. Similar to other types of machine, the output and the product size are controlled by the closed side setting CSS. In this figure, this gap is called CSS or the closed side setting of the cone crushers. This is one example production chart for the test-made SBS cone crusher. Similar to other types of crushers introduced earlier, you can use this kind of production chart to find the production capacity for a certain types of model and open side setting. So as noted earlier, cone crushers can be used in secondary or tertiary crushing. So it being used for secondary crusher, we got an open circuit. So suppose that the model is 52 SBS and the closed side setting is 1 inch. The total capacity is between 280 and 365 tons per hour. So if you use the same machine for tertiary crushing, so which means closed circuit, you got a much higher capacity from 310 to 400 tons per hour. Many manufacturers also provide you with tables to find the accreditation for the output of the cone crushers. In cone crushers, tram release system is a component that is designed to adjust the mantle positions. So it can be operated using springs, a hydraulics, or a pneumatic systems. So this is the end of this video. Goodbye for now, and I'll see you in the second video for this chapter.